In this demonstration, we'll take a look at the most commonly used devices in any number of visualizations or analytics projects. And they are very simply the mean, the median, and the mode. And the mode's the least used of these three. We definitely use mean and median quite a lot. So very basically, what are they? The mean, or the arithmetic mean, or average, is determined by summing all of the values in a given data set, and then you divide by the number of those values. So we often view this as a fairly representative value, saying, okay, on average, this is what people scored. And one of the reasons we use these central tendency markers is to give some sort of context, scale, and frame of reference to our data set. So by saying this is the central tendency, and then we spool out into the people who scored above and below, we get a better read on our data sets. That doesn't mean, however, that the mean or average is appropriate to use in all cases, but it's very commonly used. The median is simply the middle value in a data set. So as you place values in the order of magnitude, the median is something that falls between. Half the values in the data set are less, half the values are more. And the mode is simply the most commonly occurring value in a data set. And so situationally, as you learned and covered in statistics, and we have a review of the function of mean, median, and mode in the video above. So if you are needing some brush up, certainly please do take a look at that. But what we focused on is how we might use these in communicating data. And one of the other aspects of this discussion is what you read about in your book, the normal distribution. And there's also reference materials if you need a refresher on the normal distribution. There's a link above that in the section above in your course that reviews what the normal distribution is. It's often referred to as a bell curve, but the Gaussian or normal distribution is something we've all seen. It's the bell curve, and one in which the probability of a value occurring falls off dramatically the farther we move away from the mean on either side. So we have the mean, and on either side we see the frequency falling away. So it's symmetrical, and it has that characteristic shape. And those are common. For example, things like, as your book points out, the heights of adult humans, the distribution departs from the normal due to medical conditions at times, but overall, the law of large numbers, we see a fairly normal distribution. And so when we display that, we can easily display it in a histogram. And so we've already worked with histograms, but in this case, we'll review creating a histogram and showing that distribution in a histogram. So in the case of your book, the author examined runs batted in, a category of offensive statistic, calculated and kept on every batter in the game, simply meaning how many times they batted a run in to score. And so when we look at this, we would use Tableau to create a histogram of these data. So remember, we want to look at runs batted in, so that's here. And I want to create a histogram, so I've clicked on my one measure, and I can go to histogram. Okay, very good. Now I also want to filter, because what I don't want is I want to make sure that the people that I'm looking at have had enough plate appearances, or in this case at bats, to qualify for, a sample. So in this case, we look at 500 bats in a season, 500 at bats at a season as a good indicator of chances for runs batted in. So what we'll do is take the at bats or AB category and move that to filter. And I'll take all values, and I want 500 at bats. Okay, and so with 500 at bats, what we see is a fairly normal distribution so far. Not everything is perfect. Okay, we can change the binning. We go here, right? The RBI in edit. We can say we'd like to see the size of the bins be 20 RBIs. And there we go. We still have a fairly standard distribution. That might be a little much, so we could change that again. Edit. It'll suggest a bin size of 7.4. How about 10? That's fine as well. But what you'll see is a fairly normal standard distribution. And so that's the simple one, right? So we have our histogram of RBI for 2019, for the 2019 season. Okay, we can add our caption down here. There we go. Okay, so we've created the histogram, but let's say we want to get even more specific and particular. And we say, and we know that every data set has a mean, it has a median, and a maximum, and a minimum, and a number of other statistics. And so what we'll do to look at this distribution is start using box plots. And so what we can do is start using the box plot to be even more specific. And it's fairly easy to do. So if we create a new worksheet, let's go with player, position, right? And RBI down here. Okay. If we open the Show Me panel, you see that we can get a box and whisker. So this box plot, separated by position, has a minimum right here. So that minimum is called, right, that is the lowest value, excluding low outliers. Okay. This upper limit, or this max, that is the upper number, or the high number, excluding outliers. Okay. You have the lower quartile. You have the median. The upper quartile, that's 75%. So this is 75% line. Here's the 50% line. Here's the 25% line. Right? And the Boxplot showing the middle 50% of scores between the 25 and the 75 marker here. This is called the interquartile range. These lines are called whiskers, and they represent the values outside of the middle 50%. So this is the first quartile, the lower 25% of the scores. This is the upper band of the first quartile, or right, the minimum there. You've got the median. You've got the upper quartile here, right? So 1, 2, 3, 4. Okay? And you'll see how players, represented by each of these dots, fall on this line. So you'll see here's an outlier. So here's that max value, here's the outlier. Very far above. Here's an outlier here, Nelson Cruz, far above. Okay? So these are some of the things a Boxplot can tell you. They can be very helpful. Now, we also probably want to filter. We might want to filter, once again, by at-bats. Just like we did in the last one. And say we want people with only a minimum of 500 at-bats. And what we see is a much different picture. As a whole, which position tends to do better in compared to others? We see third base, the position at third base, right? The low is here, 77. The high is 126. And that's the highest low and the highest high. So these can be pretty handy as you're visualizing. So that's one way of doing it. The next way we can do this is from scratch, which is something your book demonstrates and we should walk through. So if we start by taking position and dragging that to columns, we take RBI and drag it onto rows. Okay, that creates a bar chart, and that shows the sum of all the RBIs at each position. So now we want to drag the player to detail, and we'll change the marks type to circle. So we go to the marks card, and we go to circle. Now we can go to the color shelf, and we can use sort of a transparent gray. And let's go with this. There we go, by reducing the opacity here. And we'll do a border that is dark there. Okay. So that's one way. We can still adjust the opacity. Okay. And so now we have this sense of distribution by position. Let's also filter, because we want here the same filter for at-bats. So we go to filter. Take a look at the values. 500 at-bats. There we go. Now we want to convert the dots to vertical lines, right? So we can change the marks type from circle to line. Okay, so now we've created circle to line, and then we take player and put it on the path shelf, like here. Now you've got your lines. Now, if we right-click in the y-axis, and we add a reference line, okay? And we'll do this on 3 different ways. And the first thing we'll do is add one for distribution. And we'll add quartiles per cell. Okay, so we got 25, 50, and 75. We add a reference line again. And we'll add a line. Value maximum. Okay. And undo that. Add a reference line. We want maximum. We want it per cell. I want this. There we go. And now I want to add a reference line down below. All right. And I want per cell. And I want minimum. I want label none. And I want this black bar. Okay. And I want to go back and I want to edit a reference line. There we go. There would be our box plot without the meat. And now we have a little more work to do. So we take this RBI and we drag it up to the row shelf to the right of sum RBI. So we've added the sum RBI. Now we want to make this an average. So we click here and we go, instead of measure sum, average. So we have average RBI. Notice that here in the marks card, you'll see right here in that section, you have these 3 lines, one for all, one for sum RBI, and one for average RBI. Okay? If we click in the average RBI one, right, to make sure that we've activated that part, we can change the marks type to circle here. Okay. And then drag the player field out of the marks card. And what we get are averages. Okay. So we have our dot plot of means. The next thing we want to do, okay, is we hover over this average RBI pill. We can right click on it and click dual axis. Now, that didn't quite work out the way we wanted. Why? Well, I bet if we took this @bat filter and we edited the filter and we went from 1 to 681, there we go. Now, it's not quite done, so we need to synchronize our axis. So we click on the Y axis here on the right side, and we click Synchronize Axis. Now, let me go back to my filter and see if I can go back to my 500. And that should do the trick. We can also go in here and go to size and make these smaller so they fit in there. And there you've created your box and whisker plot manually. So John Tukey invented this in the 70s. It's a very handy method for visualizing a lot of data, especially as you're looking at means, medians, and modes. The big thing is this is a more complex way of making it, and the Show Me section has a much easier way of making it. And so now you have two examples of different ways to make your box plots.